Thanks a lot for coming this early in the morning. I know it's 9:15. But so basically, keeping it solid, this talks about, that's quite loud. This talks about the solid object-orientated design principles. So this is an introduction. It is going to be kind of an introduction to the different principles. So if you already know about solid and how to apply the principles, then I'm not sure how much you'll take away from this talk. But if you don't, I'm hoping I give you something to take away. And if I don't, then I'm not going to give this talk again. So, a bit about me. My name's Joe. I'm an Android engineer, and I work for a company called Buffer. If you don't know who Buffer are, we create a suite of social media management tools, so you can do social media scheduling for different social networks like Facebook and Twitter and Instagram. We're a remote team, so we don't have an office. There's like 80 of us around the world, which is pretty cool. So if you want to know more about us, then feel free to look us up. And I write a bunch of stuff online, so check out my website if you want to see more of my work. But enough about me. So, what is solid? Does anyone here know what solid is? Cool, a few of you. That's good. So basically, solid is an acronym that's used to define 5 different object-orientated design principles. So these principles were originally put together by someone who's known in the industry as Uncle Bob. His real name's Robert Martin. He works for a company called Clean Coders, and they essentially put together a set of rules to help you write clean code, and they're advocates in that area. So using these principles together can sort of help you to make more clean code, more manageable code, and code that's more extensible. The chances are you're probably doing some of these already, if not maybe all of them, without even realizing. So I used to work for an agency, and sort of we worked on projects that are quite short scope and short time frames, and I never really had, because it was so fast paced, and I never really had a chance to sort of, I don't know, I guess I didn't realize that what I was doing was writing clean code, and it was, never had a chance to reflect. But since joining Buffer, it was the first time I started working on a huge code base that was quite old, and there's a lot of refactoring that needs to be done. And since starting that, it sort of made me realize that how many of these principles are being sort of broken and how hard it was to build on the code that already existed. So that's why I put together this talk, because, it's sort of my learnings, and hopefully other people can take these away. So the first principle is known as the single responsibility principle. This essentially says that a class should have only one reason to change. So whilst the original definition states a class, really in theory, it's not just limited to classes. This is classes, methods, objects, or even just concepts in your code. They shouldn't be doing more than one thing. So they should have one task, doing it efficiently and properly, rather than trying to do loads of different things, because eventually something could go wrong. And if you come to build on that class later, it's going to be more difficult for you to do so. So you can achieve single responsibility by applying with a goal of high cohesion and low coupling in your code. So cohesion is like how strongly related the principles and how focused the principles are in your code. And coupling is the degree to which each program module relies on other modules. So you can achieve these goals easily in your code, and it's not that difficult. For example, we could do things such as like reducing the scope of our interfaces, to make them more specific and fine-grained, or even splitting our classes up into smaller classes, rather than having this massive God activity that's trying to do everything. So a real-world example is, I've got this game on the PS4 called Overcooked, and essentially what you have to do is pick up food, cut the food up, cook it, serve the food, then wash the plates. And as soon as I started playing this game, as much as I love it, it screamed out to me how much it's breaking the single responsibility principle. As programmers, we know how hard it is to switch off sometimes. But so essentially, this is a perfect example in the real world of where something's going wrong because one person is trying to do too many different things. In the real world, you wouldn't run a restaurant like this. You wouldn't have a cook doing everything. You'd have like assistants and sous chefs and stuff. So we go back to an actual example that's kind of more useful to us, is back in the day when I started Android, you used to have this, I think a lot of people used to build apps like this, so you have this like main view or God activity, as we call them. And this activity or view or fragment will be doing literally everything. So it would be handling its sort of lifecycle changes. It would be doing the presentation of the views. It would be communicating with the data layer. It would be doing literally everything. And then you'd have some data class that would have an async task and fetch data from the API. So this, obviously, for me, was quite bad, and it sort of makes everything so coupled together and hard to maintain, because if you get a bug, what's going on? Where is the bug? And how do you find things as what's going on? And then the thing is, it's only going to get worse, because you want to build on your code and you want to add stuff. And the thing that I found looking at this old code base that I'm working on is that people just slot things in because you need to build on the code you have. And then you get to this case where this activity is huge and it just gets impossible to manage. And eventually you're going to get to the point where you have to rewrite it. So as I said, the class becomes bloated. The large scope makes it difficult to find any issues that are happening in your code, and it's difficult to build on. So I'm sure, is anyone here familiar with MVP, the Model View Presenter? Okay, cool. So I'm sure you already know the benefits of MVP. So moving away from that God activity and sort of introducing this presenter allows us to sort of separate the presentation logic from our view component. So this is essentially taking that responsibility and moving off into another class. And this is a good way of applying the single responsibility rule. So not only does it have the benefit of that, but it makes your code more testable. So we can have UI tests on our view, and we can also run unit tests on our presenter. So already, from moving that responsibility out of the activity, we've not only gained the benefit of having more manageable code, but we've also got code that's more testable. And like I said, it's not only classes that it applies to. So we have this instance of a profile in Buffer, and this profile can be like a Twitter profile, a Facebook profile, and also, other than that, it defines standard profile properties, like say a profile has an ID, a profile has a username. But also, what this profile object was doing, it had all these methods sort of checking, oh, is it a Twitter, is it an Instagram? And in theory, like, the profile object should not care about that stuff. It's already defining its base properties, and it shouldn't care about these social network sites. That's giving it more and more responsibility. And I know when you're coding this, we may look at it and be like, oh, that's not a bad thing. But then what happens when you want to add sort of more social networks, and you have to pile up these responsibilities and add to them inside this profile instance? It should have no knowledge of these types. Instead, these should be separated out into sort of another class, and the profile class should be abstracted. And this also applies to methods. So we had this post update method. Given the name, you think, oh, it just posts the update. But it wasn't. It was creating the update object, it was populating it, it was verifying the data, and it was also posting the update. So again, that method was huge, and it's too much responsibility. You should be breaking that method up into separate methods and make it more manageable. Again, if you find a bug or you want to build on it, you don't have to trace through the code that's already there. And I think one of the things that help with this is, and as well, not just methods and classes and other things, is the naming. Like, obviously this wasn't named like this, but too much is going on. If you look at the name of the concept you've created and sort of look back at the code and think, what does the name tell me that this is meant to be doing? And then looking at the code and then thinking, oh, given the name, this is doing way too much. But it's hard, it can sometimes be hard to tell what a responsibility is. So obviously, just because a class has a lot of code doesn't mean that it's not meant to be there. If we take a look at, say, the recycle view adapter. So the recycle view adapter, if you worked with a recycle view, it binds the data, it unbinds the data, and does various other things to do with adapting the data. But given its name, the recycle view adapter, that's what it's meant to do. It's meant to adapt the data to the view. So, it's not doing anything wrong. But then, say for example, if you start putting presentation logic in that adapter, then that would be breaking this single responsibility rule. So then what happens if you want to, say you add one view, or you're like, oh, it's only one bit of presentation, that's not too bad. But then what happens if down the line you want to add more and more, then this adapter is just going to get bloated with presentation logic that isn't meant to be there. So you should be thinking about it's important to think about what a class should be doing and compare it to what it is doing, and that will help you sort of filter out what if a class is breaking a single responsibility rule. Cool. So the second one is the open and closed principle. So this one is essentially says that entities should be open for extension but closed for modification. And what this is essentially saying is that you should be able to write code that doesn't need to change every time the requirements change. And in Java, we can look at this in the way of, say, inheritance and polymorphism. So if we extend stuff and implement stuff. If we go back to this profile example that we looked at before, in this profile, I know this breaks a single responsibility rule, but just for this example, we have these methods in there saying, does it support link preview? Does it support images? And these return Boolean values. And there are these hard-coded string values that are checking whether the service was equal to certain social networks. So what happens if I want to add, say, Snapchat or another social network? I have to go through this code and add checks in every single place. And this is violating the open-close principle. Because, like I said, we have to manually check each time. I might accidentally miss a method. There might be a method all the way down the bottom of the class. And it's not just this profile object that this code was found in. We also had this profile manager class, where a similar thing was going on. We're doing these manual checks for these Facebook and Twitter strings. And like I said, this is bad software design because you're just waiting for something to go wrong. We're only humans, we make mistakes, and there's going to be other places in our project where this is happening, and we might not know about it. So we might add, like I said, a Snapchat network, forget to add it somewhere, and the functionality breaks down the line. So because of this, both the profile manager and the profile are closed for extension but open for modification, which is the opposite of what we want. And how can we alleviate this? So, like I said, we want to introduce, we want to extend classes and implement classes so that we can sort of make our code more flexible. So the way that we can alleviate this is by abstracting these profile properties into a profile class. And then, from this profile class, we can take this and extend it for each new network that we want to add. So we have Facebook profile and Instagram profile. And that way, if I want to add a new profile down the line, I simply just create a new class, say Snapchat profile, and extend it. And then the rest is taken care of by the implementations of the interface, which is this. So the profile has now become an interface, which sort of declares the methods that we have to implement in these classes. So now, each profile class that we create is enforced to implement these methods, which is much more flexible. So like I said, if we add another profile down the line, we just implement this, and that new profile is enforced to implement these methods without having to worry that we've forgotten something, because it won't compile that for us. And what's great about this, and this is why it's so flexible, is because now we can pass in, we're still passing in a list of profiles, but it's much easier to validate the data. Because we have these implemented methods, we can just call profile.supports link preview. We haven't got to check each of the profile types. Is it Facebook? Does it support link preview? We can just literally loop through the profiles and check that each one supports it. And like I said, adding a new social network will never break this implementation because the methods that we need are enforced and they're implemented. So we can pass around our profile instances and check the properties using the overridden methods. So this is more flexible, and it makes our code easy to maintain. So we can alter the profile class. If we ever want to change the base class, the interface, we can ensure that if something breaks, we'll know about it because it's an interface. And if something's implementing it, then our code won't compile. So you'll never forget that it hasn't been added anywhere. And we also reduce the risk of breaking old code, because unless our requirements change due to the profile, we'll never have to change any of the other classes, any of the old code that's there. So if we want to change the values of the one in the Facebook profile, that's fine, but we should never need to touch the profile one to reduce the risk of breaking anything old. the third one is known as the Liskov substitution principle. So objects should be replaceable with subtype instances without altering the program's correctness. That's a bit of a mouthful and it may sound a bit confusing at first. It's actually quite simple. To me, it's kind of like common sense. So this essentially says that any derived types must not break the functionality of the parent types. So if you pass in a derived type to a class, then they must be completely substitutable for their base types. So in other words, child classes should not break the expected behavior of their parent implementations. So when designing software, we're constantly creating class hierarchies and extending some classes to create derived classes. So it's just about ensuring that we don't break stuff. If we do, then we can create undesired effects in our software. So for example, this is a classic example of the Liskov substitution principle, and it's really simple, and it seems a bit stupid, but it's hanging there. So the rectangle, so we have this class rectangle, essentially, and in the rectangle we can have a width and a height. So we can set a width for our rectangle, and we can set a height for our rectangle. And we know that in a rectangle, the width and the height can be different. And then we have this getArea method. Cool. So that basically returns the area of the rectangle. That's cool. So we have our rectangle object. And then I want to extend it and have a colored rectangle, which is cool. The colored rectangle behaves the same as a rectangle, except you can color it. And then I decide I want a square. So for some stupid reason, maybe I'm drunk, I decide to extend a rectangle. And we know that a square doesn't behave the same as a rectangle, but a method in my class somewhere is expecting a rectangle instance. So I want to extend it so it can still be used there. So this square class extends a rectangle, and I'm overriding these given methods. So the set width and the set height. And fine, yeah, we're setting this top one, we're setting the width, but again, we're setting the height as well. So if we remember the rectangle class, we were able to set these properties individually, except here, we're setting both of them. The problem with that is that it breaks the functionality of our parent class. So where this is bad is, say I have some method here, and I pass in an instance of a rectangle. So I can pass in anything that derives from the rectangle class. So then I set the width, and then I also set the height. And you can see here I'm setting the different properties. But if we remember in the square class, I'm setting the width and I'm setting the height, and each method is setting the properties to the same, because the square has to have the same height as the width. And then whatever I want to do with the rectangle here, say I want to get the area, it's going to behave unexpectedly, because I'm expecting that these values have been set differently, but my square class is setting them to be the same. Instead, we go back to this whole abstraction idea. Ideally, we would be lazy and just recreate the way in which this is working and have a general shape class, and then implement both of that, which makes more sense. Which is what we probably would have done in the first place, but this is just for example's sake. So we'd be modeling our classes based on their behavior rather than their properties. And to put this in another example, going back to this classic profile, so this is fine, we've got our social networks and they've all got properties that are used for profiles. But then this wouldn't make sense if we have this admin class, because this is just another example, we wouldn't have this admin class extending profile. Because it's different. It's not a social network and it behaves differently. It's going to have admin-related properties and sort of access levels, and it would completely ignore all of the things that are set by the profile class. So I like to think of the Liskov substitution principle as just sometimes not being lazy and thinking about what we're doing. Cool. So I is the interface segregation principle. It basically says that we should make fine-grained interfaces that are client-specific rather than forces interfaces that they do not use. This one is really simple. Essentially, it says avoid creating interfaces that house all of your methods. Instead, we should have smaller interfaces that are more focused into what we need. So a great example of this is I've got one of these new MacBooks, and as much as I love it, have to buy all these stupid dongles for it. So Apple have obviously been clever about it, and I can get each dongle separately. So I have a dongle for my USB, I have a dongle for my presentation thing, and then also the charger. What wouldn't make sense, I know some companies are doing this, if I had to do this, if I had to carry around a huge dongle for each different component that I wanted to put into my computer, because that would be annoying, and I'd have to lug around this massive adapter. Say I have 20 adapters in this one dongle, and I have to carry it around everywhere. It's not very practical, and it's basically, if I was only using one of them, I'd be carrying around this dongle for no reason, for just using one of these adapters, and I'd have 19 other holes that I wasn't using. So how does this apply to our code? Well, say, for example, in the buffer composer, we have this thing where you can compose text, and you can add various different attachments to it. So when a link is attached, I want to know when a link's attached, so I add an interface method on link attached. But I also want to know when this link is removed. So I add a method for knowing when this link's removed. That's fine, that's only two. But I also want to know when we attach a retweet, and then also remove the retweet. And then if the user changes the profiles, I want to know about that as well. So this doesn't look like much in our interface class itself, and you kind of think, oh, they're all related to the composer. But if I have to implement this in every single class that I want to use that interface, that's quite annoying, because I might not want to use these three methods, and I might even need the top two. So I have these empty implementations. And I'm sure we've all used interfaces from either libraries or something that does this, or even from the Android framework itself, where we have methods that we don't want to use. And if we have this in our class, then, for example, like I said, we have this link attachment view where we only use the top two, and the retweet attachment view where we only use the third and the fourth one. And yeah, it felt quite good getting rid of that. But so if you have to implement all this in all of your classes, it's just going to blow up your activities or your views. And over time, if we change the interface, we're going to have to add the overridden methods in every class that we use these interfaces, which just isn't very practical. Instead, we want to create focused interfaces with reduced scopes. It's a cleaner path to go down. So this reduces the bloating of our activities, and it makes our interfaces more reusable. Say if I want to use this in several different places, I can do, without the worry that I have to change it every time the interface changes, or have all these unused methods. I know it's a simple one, but it's kind of, again, it still applies. I think this principle and the single responsibility principle are closely linked, because your interfaces itself should just have a single responsibility of what they're giving. So as you can see, this one's responsibility is links, this one is retweet attachments, and this one is profiles. Cool. So this is the last one. It's the dependency inversion principle. So it basically, again, this is a bit of a mouthful, basically says that high-level modules should not depend upon low-level modules. Both should depend on abstractions. So again, we're going back to this idea of abstractions. To me, this is basically what Solid is about, is you want to rely on abstractions rather than concretions, because it's more flexible. So, it's an image I found on the internet. So imagine a world without plugs or sockets or any kind of socket at all. So say you go buy a motherboard, and with the motherboard, your computer, comes a mouse and a graphics card and a keyboard and other stuff, but it's all soldered directly onto the motherboard. Which, yeah, I guess if you're never going to change them, it's fine, but then what if you want to buy a new mouse or a new keyboard? You've then got to unsolder that from the motherboard without breaking anything. And then you've got to get a new mouse and connect it back and solder it to the motherboard, which just isn't very practical. You run the risk of breaking the motherboard, it's going to take you time to solder, and soldering is error prone because you don't know if the new mouse is going to have different wires. And that just sounds stupid. But the thing is, that's what this principle is about, and this is how this does happen in your code. So, say you're say you have a repository and you're expecting a certain type of class being passed into a method, and it's just not flexible at all. So say if I have something that's making API requests, and I want to add a class that allows for fetching of data from a cache. If I'm tied to a certain implementation, then introducing a new implementation to a class is just going to be difficult. So this is essentially a way of allowing us to plug in different implementations of a certain sort of approach without having to change our implementation completely. So let's look at an example. So we have this user data store, and it has two methods for simplicity. So get users and get default users. And this class essentially makes requests to the API to get our users and to get the default user, which is fine. It seems logical. And then we have this get users use case where we inject this instance of the user data store into this class. So whilst it all seems good, it's actually violating the dependency inversion principle, because our use case here is being forced to depend on this specific implementation. So it's got this link to our domain layer and it can't change it. This is bad because our use case depends on this implementation. And like I said, if we want to extend on this functionality in the future, it's going to get difficult. So whilst we're getting data from the API here, what if in a few months I decide to add caching? Where does the caching go? I don't want to stick it in there because that's for the API stuff, but where else do I do it? So how can we fix this? I did it. So data store was just this general class. Again, we're going to this idea of abstractions and interfaces. So we've moved our user data store to an interface with the same two methods, except this time they're abstract. So we get users and we get default user. And this is great because it allows us to then, we can use this interface, and in our get users use case, we can inject any type of this, any class that implements this interface. So this user data store class now allows us to sort of, we can fetch data from anywhere. We could create a class that fetches data from the API that implements this. We can then create a class that fetches data from a cache. As long as it implements this interface, we can pass in any implementation of it into this user's use case. And it has no knowledge of what method it's using. It doesn't care. It could be getting data from the API, the cache, and as long as it's getting data, it really doesn't care. So here, so like I said, we can have a user cache data store and we can have a user remote data store. And you'll see they both implement the same interface, and our use case won't know. So we can, this is so flexible because we can add any implementation of this data store class and inject it into our use case based on certain parameters. Say we only want to get data from the cache once it's expired. So if our cache is expired, we can pass through an instance of this one. Otherwise, we can pass through an instance of this one. And again, our use case won't care at all which one it's getting, as long as it's getting one. And this is good because the user data store class doesn't require changes when we add data store classes in the future. It's just an interface, and we're just implementing it. We minimize the risk to affect old functionality that's present in the user data store class, since we don't need to change it. And the user data store class is already tested, so we don't need to add unit tests to this class. This is something that working on the old code above, this is something that I put in place, and it actually paid off because we had a similar thing. We were getting users from the API, and I put this sort of approach in place. And then 2 weeks later, we thought, oh, let's introduce some caching because we noticed there was a lot of requests being made. And it's literally so easy to put in place because we had this repository pattern in place, and it literally was so easy to put in place without having to faff around. And I can't imagine having to do that stuff on we didn't have that in place. That would have been a hassle. Cool. So that's it on me. If you want to know more about SOA principles, I know this has kind of been just sort of a brisk look at them. It will sort of maybe will benefit from looking more into it if you want to. There's, if you know Realm, Don Feld has got some awesome blog posts on feature principle. It goes quite deep into them. Also, Paul Blundell from Nevoda writes really good blog posts on designing something solid. And there's some really nice illustrations that they're real world illustrations, so they're sort of more English and sort of will help you to understand it more. And if you've got a lot of time to spare, then you can read this book. It's quite big, but that's the guy who essentially invented these principles, and he's an advocate for clean code. So that's probably worth reading anyway. But yeah, that's it from me. I've still got a few minutes. Does anyone have any questions at all?